Well, hey there! Today we're going to be talking about special right triangles. Now listen closely. These two triangles right here are super duper important to a lot of different things later on in math, so it's going to pay for you to get familiar with them and get familiar fast. Now thankfully there's only two of these things, right? We got the 30-60-90 triangle and the 45-45-90 triangle. From what we know about similar triangles, any triangle that has the same angles here is going to have sides that are proportional to either one of these triangles. So for example, if I know that I have a triangle that has 30 degrees, 60 degrees, and 90 degrees, I know that the hypotenuse is going to be twice the length of the side that's opposite the 30-degree angle. I also know that to find the length of the side that's adjacent to the 30-degree angle, I'm going to take the length of the side that's opposite the 30-degree angle and multiply it times the square root of 3. Now, working with the 45-45-90 triangle is actually even easier than the 30-60-90 because it's an isosceles triangle. How do I know? Because the two legs have the same length right there. They're both x. If I wanted to find the length of the hypotenuse and I had one of the legs, all I have to do is take that length and multiply it times the square root of 2. So for today's video, all we're going to do is just kind of generalize this so that we can find the lengths of any side of a triangle that's either a 30-60-90 triangle or a 45-45-90 triangle. You see, we got 4 steps here, and they're always going to be the same no matter what information you start with. First, you got to figure out which of your triangles you're working with. You got a 30-60-90 or you got a 45-45-90. Once you figure that out, the next thing you got to do is determine which side of the triangle that you're given. Are you given, say, the side that's opposite to the 30 degrees? That would be the best situation for us in that type of triangle. We'll get into the particulars for that in the examples below. But for now, once you have that information, you're going to set up the appropriate equation from the triangle and then solve for x. And once you have x, you have the keys to the rest of the kingdom there. You're going to plug that into the remaining equations to find the other side lengths. Right, so those are the steps. Why don't we go ahead and take a look at some examples and see how they work in practice. Our first example here is asking us to find the lengths of sides B and C in this triangle that we're given. First order of business, figure out which triangle you're working with. We take a look at the angle here, 45 degrees, and that tells us that we're working with the 45-45-90 triangle. Next, we got to figure out which side we're given. The tree here corresponds with the x in the general triangle, and so that allows us to conclude that x is equal to tree. So as you can see here, the 45-45-90 triangle has legs that are the same length. What's that mean about side B? Well, to put it formally, B is also equal to tree. Now, last but certainly not least, we got to figure out what C is. C is the hypotenuse here, and the hypotenuse is defined as x times the square root of 2. Well, if x is 3, that means that C is equal to 3 times the square root of 2, and that gives us our 2 extra side lengths. Alright, that was an easy example here. Why don't we go ahead and take a look at something that's a little bit more complicated. Alright, so this time we're asked to find the lengths of sides M and N, and we start with the hypotenuse, which almost always means more work for us. Now we take a look at this 45-degree angle here, and that puts us into 45-45-90 triangle. This is going to tell us again that the 15, the hypotenuse, is equivalent to x times the square root of 2, so we're going to set up that equation right there. 15 is the same as or equals x times the square root of 2. To solve for x, we have to divide both sides by the square root of 2. Those cross out, and that's going to give us 15 over the square root of 2 is equal to x. Now, most people are going to want you to rationalize that, so we're going to go ahead and do that here. This means that we're going to set up our fraction again, pretty much the same as it was, but we're going to times the top and the bottom of the fraction by the square root in the denominator. Now this is going to go ahead and give us 15 times the square root of 2 in the top, and when you multiply 2 square roots, it's the same as taking the square root and multiplying the 2 numbers underneath, so the square root of 2 times 2. This becomes 15 radical 2 over the square root of 4, which, 4, there we go, which of course is going to give us an x value of 15 times the square root of 2 over 2. Now that we have x, we're going to plug into the other equations for the side lengths there, but both of those side lengths, m and n, go with just x by itself. So what does that mean about our two m and n values? Well, they're the same as x. 15 times the square root of 2 over 2 for m, and then n is also equal to 15 times the square root of 2 over 2. And that's the end of that. We found our two side lengths. So what we learned? We learned that sometimes we're going to have to rationalize, and we got to get good at that. Last example, find the lengths of P and, well, Q. Dang iPad with the typos. Alright, anyway, we're going to try to figure out which triangle we're starting with here, and we got the 30-degree angle. That puts us in the 30, 60, 90 triangle. There we go. Next, we got to determine which side we're starting with here, and we see that we have the adjacent side to the 30-degree angle. Now, in the general model, the 30-degree angle is in a different spot, but we still want to go with the adjacent side. What does this mean for us? Well, 11 is equal to x times the square root of 3. That's from our model there. So we solve for x again by dividing both sides by the square root of 3, and this is going to give us x equals 11 over the square root of 3. Again, we want to rationalize, so we'll multiply the top and the bottom of each of these by the square root in the denominator, the square root of 3. This is going to in turn give us 11 times the square root of 3 over the square root of 3 times 3. And this becomes 11 radical 3 over the square root of 9, the square root of 9, keep in mind. And this means that x is going to have a final value of 11 times the square root of 3 over just plain regular 3. So we return to our model here and try to figure out what P and Q are. I see that x is the value that's opposite the 30-degree angles right here. Opposite, right? So in our triangle, the side that's opposite the 30 degrees is P. So what does that mean? It means that P has the same value as x, or 11 times the square root of 3 over 3. That's our value for P. Last, we got to figure out our value for Q. Q is going to be the hypotenuse of this triangle, and according to the general model, the hypotenuse is 2 times x. If x is 11 times the square root of 3 over 3, to figure out what Q is, we're just going to double it, aka 2 times 11 times the square root of 3 over 3. Now we could turn that 2 into 2 over 1 to make our fraction operations a little bit easier, and that's going to allow us to get a final answer of, drumroll please, Q is equal to 22 times the square root of 3 over 3. Bingo! And that's a pretty good introduction to special right triangles. Once you determine you have something that's either 30, 60, 90 or 45, 45, 90, you're going to see which side you're given with respect to the model. You're going to solve for x, and then you're going to associate the remaining sides with their corresponding sides in the model, plug in for x, and then get the values that you want. Now remember, you're also probably going to have to rationalize at some point in the average special right triangle problem, so if you're not sure how to do that, go ahead and watch the Auducation video on rationalizing denominators. Other than that, just watch this again if you're confused and definitely get some practice. See ya!